And welcome back. So I understand this lesson's going a little bit longer than perhaps anticipated. I will do my best to, cut down time in some of the later lessons of this week to accommodate the fact that this one did run a little bit longer than expected. But I want to go ahead and finish this up because hopefully this last kind of section here will take less time than expected. But what we want to look at here is how can we define higher order functions that accept either function point that accept function pointers and function objects. If we go ahead and look at our implementation of filter movies with function pointers, where we said that filter is going to be a pointer to some sort of function that returns a Boolean value and takes a single argument of type movie. Notice here that this parameter is expecting the address of a function. So when we're invoking filter movies and the parameter type of filter is as specified, we better be passing a function address to it. That is not going to cut it if we were looking to pass, say, a function object to this filter movie. Do you see the problem here? A function object, so some object type t, is not going to meet this criteria of it being a filter of the object being passed of the expectation of the parameter. And that is, again, a pointer to a function that returns a Boolean value and who has a single parameter that takes a movie object. Likewise, if we look at our implementation of filter movies with function objects, filter was simply, and in hindsight, we could have maybe passed this by constant reference. It's just being passed by value here. Let's keep it simple. But filter was some sort of object of type t, which meant we could initialize it for any type t. A function address is not going to cut it in this case. As we continue to kind of look through this definition, we can see here that, well, any type t that is a function object that has the call operator defined for it will be a valid object of type t that can be used within our filter movies function. So now the question kind of becomes, well, this is restrictive. In these two implementations, we have one that only accepts function pointers and another that only accepts function objects. Is there a way to kind of craft our filter movies in a way that it would accept both function pointers, so addresses of functions, as well as function objects, so any sort of object that has the call operator defined for it? And well, if we go ahead and we look at this definition, the one we originally considered in the previous lesson, we saw the standard template library function type. It was a class template. And then, the template arguments here were listed kind of funky. Let's not worry about that. But the key thing here is filter was type standard template library function, meaning that in this case, this type would bind to any function address that met the criteria. So as long as it had a return address of type bool and took a movie by constant reference or reference to const, this type could accept addresses to functions that met that criteria. In addition to that, this function also would accept types of objects who had the call operation defined for them. And the call operator had to be defined as, well, meeting the specification, returning a Boolean value as specified, and then also taking a movie object by reference to const. And we can see here that our function object also meets this criteria. So standard library of function, this type here, it's going to allow us to define high order functions that are able to accept both function pointers and function objects. And what we will see tomorrow is that it also will accept lambda functions that meet the specifications noted here. So with that, we're done with today's lesson. I hope this stuff is clear. I hope it makes sense, and I hope you learned something. So with that, I'll see you all tomorrow. Bye-bye.